This video segment will cover how to use the high-resolution force probes to make the measurements necessary for Archimedes' principle or the buoyancy force, which are basically the same thing. Now, presumably you've seen the videos on the introduction to the buoyancy force and also the one on the high-resolution force probe, so this is going to be very specific to how to operate things. And it is designed to help you if you're actually doing the experiment, and if you're in a remote situation, then at least it'll show you what does happen on the experiment. We have 8 different cylinders here, well 7 on this thing and the 8th one coming up. We have various lengths. They're all the same diameter. They're made of different materials, so they have different masses. Now the first thing, if you're actually doing the experiment, we want to, when you take the cylinder out of the rack, grasp the cylinder, not the fishing line it's attached to. Now what we're going to do is start data acquisition, which you can't see me press the button, but it's over here. And I will show you the screen later, but we're going to get all the data. And I'm also going to do a couple of things that are not a little bit add-ons, just in case someone's curious. So the first thing we're going to do is zero the force sensor, as discussed. And once it's zeroed, we will hang this weight, this cylinder, on the force probe. We will allow several seconds to collect data. Okay, we have enough data collected now. Now I'm going to submerge it in water, but one of the things I'm going to do is actually submerge it about halfway, then complete the submergence. So I'll just gradually increase it. It's about halfway submerged right there. And now I'm going to completely submerge it in the water. And of course the halfway submerged is not really a data point. It's not that accurate, but at least give an idea. And now we will allow several seconds to the data to accumulate. And we have plenty of data right now. So the last thing I want to do again is if you go deeper in a liquid, the pressure gets greater. So the question is, does the buoyancy force go up? So what I'm going to do, I'm going to just jiggle this thing to put a mark in our data collection. That'll mark when I made that. And I'm going to submerge it deeper, being sure I'm not actually touching the bottom. And we'll get some more data collection. So now we have enough data. We will stop the recording. We will take a good look at our computer screen here and zoom in on it. So the first thing I'm going to do is get a data analysis window, and I want to zoom in on this because this is an area that students ask about a lot. In order to get that, you have to go up to the bar on the top here and get the one with the 3 blue dots and the yellow pencil, and that gives you the block here. Once you have the block here, it's easy. Everybody can figure out how to move it around. So let's take a look at the data we got. Let me zoom back so you can see the data better. We have when I first started the acquisition, then when I hit the 0 button. So this gives us true 0. And then we have a section here with the cylinder simply hanging in the air. So we get our block. Get it down so it fits inside here. And we have the mean there. It's 0.3308 newtons, and it gives you the standard deviation. Then the next thing I did, I halfway submerged it. Then I fully submerged it. And we're not really trying to measure the halfway submerged, but it looks like the buoyancy force, which is the difference between the force when it's in air and the force when it's submerged, is we had about half the buoyancy force when it was half submerged, and that makes sense. So I'll move over here, and we have the reading here of 0.209 newtons. And we have a glitch right here, which is where I put my finger on the hook just to mark it, and then we went deeper. And you can see, the buoyancy force did not change for going deeper, so you can figure out why that is. So I hope this will let you do the experiment, or at least understand how to do it.